Good morning and welcome to business math class. I passed out the test and was really pleased with how, everyone did on it. I'll be glad to go over any specific questions that anyone's got at the end of class. If you want to go over it, I actually brought the key. Generally what I try to do is on problems that you've missed, I fill out the rest of the work and try to show you what's going on. So you might take a minute and look over that, and then I'll get with you after class if you've got questions on that. We covered 6.1 in our last class session, and we are still at a point where we're using whatever calculator you're comfortable using, but we're getting very close to the point where you have to have the financial calculator. I would really encourage you to get that financial calculator and start using it. You're more than welcome to have two calculators with you, a scientific calculator and this financial calculator if you want to, but the financial calculator works differently. And it's kind of nice if you get an orientation to that financial calculator during this section so that it's comfortable when we start having to use it on a full-time basis. Questions about the financial calculator? The one that you really do need to use is the Texas Instruments BA 35. It's available here in the bookstore at Johnson County Community College. It's about $20. They also have it at all the discount stores. The difference between a financial calculator and a business calculator is the order of operations. If you enter information into a scientific calculator, some other calculator that you've been using, if it is not a business calculator, is anyone familiar with the words PEMDAS? Please excuse my dear Aunt Sally. PEMDAS is the order of operations in a scientific calculator. It does parentheses first, then it does exponents, then it does multiplication and division in order in which they occur left to right, then it does addition and subtraction in order in which it occurs left to right. A business calculator, however, handles all information left to right. Okay? So if I did 2 plus 3 times 5. And I entered that into a scientific calculator. It would do the multiplication first. The answer would be 2 plus 15. The answer would be 17. That would be in a scientific calculator. Okay? However, in a business calculator, it would just go left to right. 2 plus 3 is 5 times 5. The answer would be 25. So the correct answer to that problem could be two separate things depending on whether you're using a business calculator or a scientific calculator. For a math class that you would have taken in high school, the correct answer would be 17. But in a business calculator, the answer would be 25. So if you've got a calculator and you don't know which it is, that's what would let you know that is the most important difference. The other thing that happens in a business calculator is we don't have any grouping symbols. We don't have any parentheses on this one. So since we're going to kind of need parentheses, we're going to do some things to store some information so that we don't need parentheses. Are you with me? But if you have a scientific calculator that had parentheses, you would be able to use the parentheses and take care of that. So that's kind of, there are differences. And the most important set of differences is the set of buttons that go across here that say N, %I, PV, PMT, and FV. We have to have that in Chapter 7 and Chapter 8. Some of you will have a TI-83 that you've got left over from some class you took prior to this. The financial stuff is in there. You'll be responsible for getting to the Math Resource Center and finding that. But anyway, that's my calculator pitch before we get going. But if you've got this calculator, I would suggest that you start using it right away, so that we kind of get comfortable with it, because we will absolutely have to have it after the start of Chapter 7, very first day. Okay? Questions about calculators, because I heard some of you asking about that earlier. And again, on this homework and on the next test, you're more than welcome to have both of them around. Did that answer calculator questions? Okay. Questions on the homework on 6.1? I felt like when you left here you were pretty self-confident. We, in 6.1, used the formula I equal PRT. We always had P, principal, R, rate, T, time, and we were calculating the interest. Sometimes, however, with those four pieces of information, I, P, R, and T, we do not have the PRT wanting the I. We have other pieces of that. So that's what we're going to talk about today. What if I need to find the principal? What if I need to find the rate? Or what if I need to find the time? I'm real proud of the fact that I was able to do this little graphic because I'm not much of a computer expert, and you'll never appreciate the hours that I spent getting this one done. But and I've had it lopsided and I've had it many different ways. But at the top of this page it says I. And then it's got PRT, and if you can visualize that, it will really help you when we come to the formulas for things other than interest. When I'm looking for interest, I cover the I, and the formula is P times R times T. Is that okay? If I need to find the principal, I'm going to put my finger on P, and it's I divided by R times T. Is that one making sense? Do you see it? Great. Put your finger on R. When you're looking for R, it's I divided by P times T. And if you're looking for T, it's I divided by P times R. Instead of having to memorize all of those formulas, if you can memorize the graphic I over P times R times T, you just cover up the one you want. You need to have all three other pieces of information, but you don't have to keep track of when you multiply and divide. You'll automatically have the formula. Is that okay? Everyone understand what we're doing? Great. Then what we're going to do is begin by looking at number one. It says, find the principal if the interest is $17.06, the rate is 7.5%, and the time is 2 months. So to begin with, we need to come up with the formula for P. So P equal, put your finger on P, it's I divided by R times T. We don't have to memorize it, we can just use the graphic to come up with it, okay? So now we need to load the information into that formula. What was the interest? What was the amount of the interest? I equal, no, that would be the rate. I want to know the amount of the interest. 1706. And the interest rate was, as a decimal, as, say it out loud, 0.075. And the time is 2 over 12 because it's 2 months. This is where we run into some issues with this calculator. You cannot enter 17.06 divided by 0.075 times 2 divided by 12. You will not get the right answer. There are a couple of things that you can do to take care of it. We actually need to group the numbers on the top, group the numbers on the bottom, okay? There are two ways of doing it. We can go ahead and just take care of the denominator. In your calculator, put 0.075 times 2 divided by 12 and come up with a number. What'd you get? 0.0125, which you can write down. And then take 17.06, then go back and take 17.06 divided by 0.0125. And you will come up with the right answer. I have a better way, or a way I like to do it better. It's my preferred method. What did we get as principal? 1364.80. When this number that's in the denominator terminates, it's okay to write it down and then re-enter it. But you know what I like to do, don't you? Store it in memory. That's exactly what I like to do. When I come and work with this problem, I like to take let me get my calculator up here. And I know that's hard to see, but I would take care of that denominator. I would go 0.075 times 2 divided by 12 equal. I would then store that number Now it's in my memory. Then I would do 17.06 divided by recall second mem. It'll pull that out of memory, equal, and I come up with my answer. If you have a repeating decimal, you don't have a choice. You sort of have to store it. So I just always store it. Josh happens to have a calculator I can see that's got parentheses. Right, Josh? Right. What he could do with that one, if you have a scientific calculator and not the business calculator, you can do 17.06 divided by open parentheses. Does that make sense? Group that bottom, 0.075 times 2 divided by 12, close parentheses equal, which is why I said some people will choose to have two calculators, a scientific and a business one. I just think the business one is easy to work with. You just have to store those denominators. Is everyone getting the correct answer? Either writing it down, storing it, using a scientific calculator with parentheses. Okay. So try setting up problem 2 then. It says the principal, find the principal that would give you simple interest of $229 if it was 8% interest for 6 months. Interest rates have gone down since I wrote this. They just recently went down again. So these are kind of big interest rates right now. To begin with, we want to come up with the correct formula for principal. Look at the graphic. The minute you see the word months, you know that the denominator of time is 12, 6 months. So we're going to do 6 divided by 12. Who thinks they've got the right answer? Patrick, what'd you come up with?
Number 2, I got 57.25.
57.25. Anyone agree or disagree? Agree. Anybody having trouble getting that answer? Great. Next problem. We're going to find the rate. It's money is invested for 60 days ordinary, and it earns 40% in simple interest. First thing you need to do is think about the graphic, cover up the R, think what it looks like. So to begin with, the formula for rate is I over P times T. Everyone see where he's getting that? Great. Now we're going to say rate equal. And is rate going to be a percent or a decimal? It's going to, whoa. Rate's going to be a decimal, that's right. If we're actually wanting the percent, we'll convert it when we get done. It's going to be the decimal. So how much interest did we earn? I equal 40. Right? How much principal did we have? 3,000 times, and the time is 60. Good. Right. If that had been exact, it would have been 60 divided by 365. Okay. Once again, take care of the denominator first. Get it stored. Write it down. Or if you've got a scientific calculator, use the parentheses. R equal. Somebody back there. Allison, what'd you get? Are you there yet? Does Keith have it? 0.08, which is a decimal. And if I wanted to know what percent that was, what would the percent that decimal equals be? How much? 8%. I'm happy with 0.08, but we should, with no problem, be able to convert those. Is that one all right? Great. Next problem is an exact one. It also deals with days, but we know when we say exact, our denominator is going to be 365. So I want to find the interest rate. that earns $5.78, 30 days exact, $600 was invested. I don't know. Does that look right to everyone? Carrie, did you get an answer yet? Number 4?
Number 4, my answer was 11.72%.
11.72%. That's right. We ended up with a decimal that's 0.1172. And as a percent, it's 11.72. Again, that's pretty big numbers for today's interest. You can tell I just sort of make some of these numbers up as I fly by. That's right. Okay. Suppose that $800, this is top of the next page. This one is a mini multi-part problem. $800 is deposited at 6%. It earns $28 in interest. Let's find the time in years, months, weeks, days, both ordinary and exact. I like to say, I'm going to give you nothing, you give me everything. So I want time. Think of the graphic, time equal. What does time equal? Keegan, do you know what time equals?
Interest over principal times rate.
That's exactly right. And what I like to do with this one, time is always in terms of years. So time in terms of years is interest divided by principal times rate. So when we get the answer to this one, that's exactly what we're going to do. Yeah. So let's start out with time in terms of a year equal. The interest was 28. Does that make sense? And then we had $800 in principal, and the rate was 0.06. Time in terms of a year is how much? It's not a nice, neat number. That's right. That's what, more than half a year. Yeah. So when I think about what kind of answers that I might have, when I get it in terms of month, it's better be more than 6 months. When I get it in terms of days, it ought to be more than 180. Yeah, because there's 360 or 365. And in terms of weeks, how many weeks are there in a year? 52, so it'd be better be more than 25 or 26, right? Okay, and you're exactly right. We're going to change this to each one of those different time units. So if I want it in terms of a month, I'm going to take that number, which I need to store in my calculator, right? So I can pull it back out and use it over and over and over. I want to take time in terms of a year, and if I want it in terms of months, I'm going to take time in terms of a year times 12. And how many months does that give me? You should have stored 0.583 repeating.
6.9999.
So it's about 7 months. Cool. What if I wanted it in terms of weeks?
30 1/3.
Yeah. I take this time in terms of a year times 52, and he said I got 30.3 repeating 30 1/3 weeks. Talk to me, Karen.
I'm just trying to squint through the lights.
Oh, okay. Do you want to scoot down? Would it be better? Or are you seeing okay?
Yeah.
Okay. Did you get time in terms of a year loaded into your calculator's memory? Do you need help? You're just saying that.
No, I'm just doing a little different though.
Okay. That's fine. And you're happy with how you're doing it. That's fine. Are you getting 30 1/3 or 30.333 repeating? Good. Okay. If I want it ordinary and day, I'm going to take time in terms of a year. I'm going to multiply it times 360. And how many days am I going to have ordinary? 210. That's right. And if it happened to be exact and days, I'm going to take it times time in terms of a year times 365, and that'll convert to, that's what I got, 213. And obviously these times are going to need to be rounded a bit. They're approximate. Because you know we're not paying interest on a third of a day or a 7/9 of a day or something like that. I'm going to round those. But I think in the homework they're going to ask you to do some of these conversions to different time units. And you've got to remember that when you get time in your calculator, it's always time in terms of a year. So whatever other unit of time they want, you've got to convert time to those other units, because what you get out when you solve for t is time in a year. Great.
Your time is 583.
0.583 repeating.
So when you're doing your months, time times 12 is 7 months.
Mm-hmm.
So are you doing, oh, I was on the other sheet.
It's okay. It's okay. Did you get this? Come back here to 28 divided by 800 times 0.06. And did you get this number, 0.583 repeating?
Yes.
Take it times 12.
It's 7.
Right. So it's 7. When you take it times 12, because that's how many months there are in a year, that's the part of a year it is, the decimal part of a year, 0.583. And we were saying if it was 0.5, it would be exactly 6 months. It would be a half a year. So it's more than a half a year. That's the part of a year it is. Does that make sense, Christine?
For some reason I didn't get, I don't know, maybe the weeks. I didn't get one of the answers right. That's why I had the question.
Are you storing 0.583 repeating? Okay. Then take that and recall it. Take it times 52. Recall second mem. And I do like storing these. When we're going to use a number over and over, I hate having to recalculate the number. It is very nice to look ahead and see that we're going to use it and be able to store it and pull it back for multiple calculations. Yeah. And sometimes we just hit the wrong number by mistake, and that's the reason I always say on tests and homework and stuff, show me all your work, because when we're using so much of a calculator to determine stuff, if you don't show me what you entered but then you get the wrong answer, I have no idea if you were on track or not on track. Where often they'll have everything right, but then enter it wrong in the calculator. You really don't know if you've entered it right. But if you've shown me everything, I like to give you partial credit for that. Okay, is everyone done with number 5 and understand what we're doing there? Great. Read problem 6 then and find out what needs to happen. It says Walt borrows $60,000 at 9% to redecorate his bed and breakfast. He agrees to repay $61,800. Find the time in days and the amount of interest he paid in ordinary simple interest. Well, time is equal to, this is a trick. You have to be thinking about it, right? And it's also a plan ahead for next section of the book. We know that time in years is equal to I divided by principal times rate. Is that true? Question is, how much interest is Walt agreeing to pay? How'd you get $1,800?
So subtracted the principal that he borrowed from the total he's repaying.
And this really is where we're heading. We're going to start talking about what you owe. And obviously, what you pay back is more than what you borrowed. The money that someone gives you, right? Then you use that money. Interest is money that you pay for the use of someone's money, or money that someone pays you for the use of your money. And so what you pay back is more than what you got to begin with. And the difference is the interest. And that'd be a perfect example of that one. We're going to head into that a little bit later. The word for the amount that you pay back is the maturity value. So the maturity value of his loan was $61,800. The difference between what you get when you borrow money and what you pay back is the amount of interest that you paid. So you're right. The interest is equal to $1,800. Sometimes you have to think through these problems. They don't give you all of the information. You have to make some calculations. You can't just use the numbers you're given. And I think all of you would have known that, but it's going to get a little more complicated next week. You know, the stories get a little more complex. So then how much he borrowed was the $60,000, and we're going to take that times 0.09. Time in terms of a year then is .3 repeating is what I got. Agree? Did I mess up or?
400, wasn't it?
Excuse me?
5,400.
Yeah. That's what I got for the denominator that I stored. So it would be 1,800 divided by 5,400. Sometimes those denominators turn out nice and clean.
5,490.
What number?
Oh, it's 60,000 in it.
And what are you using?
61,000.
Oh, thank you. He just made one of the most common mistakes, and that's using the wrong parts. I mean, they give you all these numbers, and you've got to pick and choose. And he was using the maturity value as opposed to the principal. And those are the kind of things that, when you check the answers in the back of the book, don't assume they're wrong. Assume you're wrong and reevaluate. That's right. How much money did he actually get? Principal was $60,000. So now are you getting 0.3 repeating? Great. We do need to store that one. Take that, if it's ordinary, times what number? 360. And what do we end up with? How many days did he borrow that money for? 120 days. A lot of interest. Of course, he had a pretty good amount of money that he borrowed. And if we wanted to convert this to exact, we would have taken it times 365, and we could have done it to weeks by taking that same times 52. If we wanted to convert it to months, we could have taken it times 12, right? So we can convert these to any. You just need to know that it's years to begin with. Great. Okay, then I'd like for you to open your books to page 198. That's the homework for 6-2. And we will look over the homework and see what kind of problems, because you seem to find the most interesting questions when we do that. And make sure that we're not going to have any questions when we go to do our homework. Take a minute and peek at those problems, 1 through 27, and let's see what you want to do. They're knocking stuff down in the back of the room. I'm going to grab my book from underneath here. And the minute someone's got a question, we'll do it.
On 15, we're just finding the principal.
Yes, when it says find the amount of the deposit, and we can do that one. Kelly received $175 interest over the past 3 years on a deposit earning 4.5% simple interest, find the amount of the deposit. The amount that's deposited originally is the principal. Likewise, on 17, it said Jack paid interest. How much did he borrow? The amount that he borrowed originally was the principal. What are we going to do on problem number 5? Why don't we try to do 5 together? Why did I pick number 5? It's got that third. That's exactly right. It says find the principal when we know what the interest is, we know what the time is, and we've got that third. Those they're called irrational. They go on and on. They not irrational. They're called think of the word. They're just they don't, well, they're non-terminating. They don't stop. It goes on and on forever. So we can't store them. They're not clean numbers. Let's do that one. Interest is 37.50. They're rational. They just are non-terminating. And we've got 8 1/3% times 270 in its days, and we're going to assume that it's ordinary, and it says it's ordinary. Okay. When we've got that third, what we really need to do with that is take care of that denominator. So we're going to do 1 divided by 3 plus 8. Divided by 100, right? Then take that times 270 divided by 360. We've got to take care of the third first. Does that make sense? So let's do 1 divided by 3 plus 8. Then we're going to divide by 100. That actually comes up with 0.08333 repeating. Yeah? Then we're going to take that times 270 divided by 360. Actually, that doesn't end up with a very ugly denominator, does it? I ended up with 0.0625, which I'm going to store. And then we're going to take the 37.50 divided by 0.0625. And we say the amount of money that we borrowed was $600. So you're handling those all right. Okay. Likewise, we're not doing number 6, but if we were, it would be 2 divided by 3. And then we'd go plus 6 divided by 100. Is there anything else in that homework that looks like we need to talk about it? If not, we're going to let them turn off the tapes. I'll let you keep working on your homework, and we can discuss anything anyone wants to about the test.